The Moss Report is brought to you by MycoLife, makers of the world's best mushroom extracts, including the Moss Method mushroom formula, available exclusively at mycolife.us. Hello, healers. My name is Ben, and this is the Moss Report. I'm here today with my father, author and founder of the Moss Report, Dr. Ralph W. Moss. Good morning, Dad.
Good morning, Ben.
So today, you're going to be giving me a lesson on how to identify the quality talking points or the quality points of a scientific study. I'm so excited about this. You know, I've been asking you to do this with me for years. And I'm glad that we finally got around to making this one a priority for our podcast, because I think it's going to be very instructive for me and for everyone who's listening. So if I understand, you had gotten an email from me that I forwarded to you from a viewer. And I thought it sounded interesting. And you had a response, and I said, well, I need to know this in the context of how does a paper or a study merit further investigation in your mind? So I don't know where you want to start, but that's the topic for today. And as I say, I'm very excited to get into it.
Well, I hope I have answers that can satisfy you, because I've read so many scientific papers in my life. I mean, starting in 1974, it's the main thing that I've done. And one time I calculated that I must have read like 100,000 papers, or at least abstracts of paper. I won't say, every detail of every paper. So if I don't know by now, how to spot a good paper, then I don't think I'm ever going to learn in the next 50 years. But like anything that becomes second nature to you, it's hard to pinpoint what it is that, makes for a good or great paper. And I would say it's sort of like the editor at a publishing house who gets a stack of books, to look through and pick out the ones that they're going to put the money on and, actually publish. They'd be hard pressed to say exactly what it is that makes for a great book or great quality in a paper. But I'll try. All by way of saying, I can give you some of the criteria, but there is sort of a intuitive aspect to it as well.
Okay.
So I think that the first thing is that a paper, and we're talking now about scientific papers, because we should explain to people that not everything that a layperson would think was a paper has the same quality. What we're talking about are scientific papers that have undergone peer review, meaning that there's a process already in place at the journal where the paper is published that weeds out gross errors, falsehoods, and incompetence. So these are all journal articles, and they're all articles that have been subjected to this process.
Okay, well, but before you get into that, so how do I know right off the bat if something is a peer-reviewed paper? Does it announce that right at the top, or is it just by dint of it being in a publication of a certain type?
Well, almost of those 100,000 papers, about 99% of the papers in PubMed are peer-reviewed. It's almost the basic criterion for a journal to be included in the PubMed database is that it be peer-reviewed. And that's a formal process. And I've had the honor and privilege of being a peer reviewer for about a dozen journals over the years. So it's a standardized thing. And it can be, questioned whether or not there's sort of a buddy system at work, because sometimes the the authors of the paper get to suggest the reviewers, especially in a topic that's less common. But by and large, it works. By and large, the system does work and it does hold. So I think if it's not in PubMed, and there are journals that are not listed in PubMed, and there are journal articles that are not included, but those have a much lower likelihood of fulfilling all the requirements of a really good paper.
Okay, I have a follow-up question to that. So the peers in the peer review process,
Yeah.
are they vetted or do they have to be credentialed or how does that work? I mean, can anybody off the street become a peer reviewer? And I guess because I think about it, it's like if I'm if I'm one of the peer reviewers, in a way I'm putting my reputation on the line by stating unequivocally that the scientific method behind the research or the data that's being presented in the paper is, to the best of my knowledge, valid and adheres to best practices. And if I'm going outside of that, then I'm signing off on something that, if it's called out, it would affect my reputation. But
Right.
if I don't have a reputation, then who cares?
Right. It's a perfectly good question, but in my experience, I mean, it rarely ever comes up because the editors of the journal, who are the ones who assign the peer reviewers, are intimately familiar with their own field. And so they know who is reputable and who's not, or like in my case, because I was co-author on some papers relating to specific areas in like immunotherapy, because of my reputation and related to those other publications, I was asked at times to be a peer reviewer. But mostly, they're academics, they're professors or doctors at established hospitals. And sometimes as I say, the author or one of the authors or the senior author of a paper would suggest to the editor, well, I think so and so would make a good reviewer. And then the editor would go online or make some phone calls just to make sure that that person who's been recommended it's not just a buddy system. They're not just recommending their friends.
Got it.
And they can't be people who are vested, who have a financial interest in the outcome
I see.
of the paper.
So that is a criteria.
Yes, I don't know that it's a hard and fast criterion, but it is certainly part of the process. If you're looking for peer reviewers, you want to get objective people who are not themselves involved in that particular study. Oftentimes, they could be the rivals of the people who wrote the paper.
Uh-huh.
But you want to get as distinguished a group, and usually that's kept confidential, who the
Oh.
reviewers are.
Oh, is that right?
But not always.
Uh-huh.
Sometimes it's actually in modern times they sometimes list who the reviewers are. That's uncommon, but I don't see the system breaking down at that point. You know what I mean? I think that given the tens of millions of articles there are in PubMed, there have been very few scandals of like people faking the approval.
Mm-hmm.
If anything, I would say that sometimes the reviewers are very picky to the point of, I mean, just tear your hair out. Some of the papers that I've worked on as co-author took more than a year, maybe a year and a half, to get through the process of peer review.
Hmm.
And the more controversial the topic, the more closely the reviewers are going to look at it. I can't recall any paper that I submitted that ultimately wasn't published, but I'm remembering the paper that I co-authored with Ralph Kleef in Vienna, somebody that you knew very well, he passed away. But I think that took us about 2 years. Now, part of that, to get to between this time we submitted the paper and the time that it was published, part of that was because there were like 8 authors on the paper, and everybody who was involved had to then be involved in the process of rewriting. So it became cumbersome. But that's not uncommon. The paper that I want to talk to you about today, I didn't count them, but there must be 50 authors on that paper.
Oh, wow.
And, and,
Huh.
e- and in some sense, each one of them has to agree to all the changes.
Okay.
So it's a cumbersome
Well,
process.
off the bat, I would say having 50 authors sounds like a quality point, but
It
maybe not.
is. It usually is. When, they say,
Okay.
what
But
is
not
it?
always.
Not always,
Okay.
but they say that success, failure is an orphan and success has many parents. So you notice with important articles like the article that announced the discovery of the first immune check inhibitor drugs. There was a famous paper out of MD Anderson, I believe, and there were, 50, 100 authors because everybody wants on to that paper because then they become co-discoverer of the immune checkpoint inhibitor drugs, you see, or something with Ozempic or some of these, papers that are going to be historically important. Well, it's a career builder to be associated with that in any sense. But it's an elaborate machinery that operates behind the scenes in biomedical research worldwide. And so not every paper, of course, gets that kind of treatment. And then there are some papers, I've done
Yeah.
some papers that were not really peer reviewed. They appeared in medical journals, but they were like opinion pieces. So like for instance, I had a letter in Journal of National Cancer Institute, and I had another letter in the Journal of the American Medical Association. And I think in those cases, it's the editors who basically function as the peer reviewers because you're not proposing research, you're not putting forward something new in terms of findings. You're putting forward your opinion usually about some other research. So there are exceptions, but it's in the context of a carefully reviewed situation.
So, for our audience, though, would it be fair to say that if it's not in a peer reviewed journal, you wouldn't give it credence?
I wouldn't give it the same credence as any article that was not peer reviewed.
Okay. But it still might be interesting, but
Correct. Oh
less
no,
conclusive, I guess.
absolutely. And we've had much input from various people who had interesting theories or ideas, but it just doesn't rise to the level of scientific fact. And I'm thinking a particular person who's a fountainhead of interesting ideas. You know her. I won't mention any names, but it's not. It's her like her reflection on her practice, and it's put forward in either there's no journal associated with it. It's just a paper sort of floating out there in cyberspace, or else. And here we get into the question of just using your nose to sort of see
Right.
whether this smells right or not. There are journals out there that are just dubious.
Yeah.
And this was not a problem 25 years ago. This is an internet phenomenon, but at a certain point, out of a good motive, basically good motive, the a movement got started to make free full text articles available, which is wonderful from the point of view of doing research because you can imagine, I mean, the bill that I would have run up over the years in terms, if I had to pay 39 or $40 per per article, which is not uncommon in terms of what publishers used to demand and still demand for access to the full text article, it adds up very quickly when you need to go through 50 or 100 articles to write something about a topic.
Right.
So there was a big move towards a free full text, but the other flip side of that is that somebody has to pay for the publication. If you're offering the paper up free without there being a subscription charge or a charge for per article, and that oftentimes was the authors of the article. So, and that gave rise to a whole industry of pay to play journals. This introduced a level of uncertainty into the whole publication business, of medical publication business.
I can imagine. I'm thinking that probably most of the articles that you go through, the scientists or the researchers that are working on producing that paper are not doing it in order to gain royalties from the publication itself. They're putting forth their research and hoping to get acclaim in the scientific community and boost their own process of maybe getting funding for their
Career.
research, for their funding or investors or something along that line.
Or career, or advance their careers, like publish or perish. They need to show that they have a publication record. So what happens is that, and I'd say hardly a day goes by that I don't get a solicitation for the exact, not only for that, but I get almost every day a solicitation to chair a section of a meeting or a whole section of a journal. And how do they know me? Because of prior publications, valid publications that I was involved with. But there's massive amount of this sort of pay to play business going on, and it's become very difficult to know whether or not the journal you're dealing with is a legitimate journal or it's something fringy. Fringy in the sense that the authors had to pay thousands of dollars to get the thing published. Now, how much could you trust that there really was peer review in a journal
I see.
where the journal has the owners of the journal have a tremendous vested interest in getting that thing published? So I think it's a shady area that didn't exist or hardly existed 30, 40 years ago. And now it's become a big pain in the butt that you have to worry, is this really something legit or not? And
So when you say pay to play, you're talking about a would-be author of a paper paying to get a journal to publish
right,
that then they can say this paper is in a peer-reviewed journal.
right,
And then also you're talking about the journals themselves monetizing that content in order to get people to buy those papers.
right.
And maybe the more popular or clickable the topics,
Yeah,
that the more money that they make. So I think I see there could be a conflict of interest in both of those things.
yeah.
So,
It's a big
okay.
problem.
And that gets us into PubMed. So if someone was doing some research on a topic and they wanted to learn more and they did a search for something on PubMed and there was 1,000 articles on that topic,
Yeah,
and many of them, as you said, have abstracts, but then in order to read the full text, you sometimes can find it for free, but other times you have to pay something,
that's
40 or
right.
$50.
Right.
So how would a person know whether or not the peer-reviewed journal that they're looking at is a good one? Just I know you have the experience to know which articles have been published in which journals over the years,
Right.
but is there anything actionable for a curious layperson or even a professional who might be trying to do their due diligence on a topic and pick which articles to invest their time and resources into?
Well, yeah, I mean, there are criteria, and I don't want to overstate this because PubMed itself is a filter.
Okay.
PubMed doesn't, just because you claim your peer review doesn't get you into PubMed.
Oh, is that right? Okay.
Yes. So there is already a selection process underway. And then I would say, so what are the main criteria? I would say, first of all, it has to be important enough research question to be worth your time to even look at. So let's assume for the moment, though, that now we're in PubMed and we have faith and trust that PubMed is doing its job, which I believe it is. And so they're
And it's run,
presenting.
I'm sorry to interrupt, but it's
Mhm.
run by the National Institute of Health. Is that right?
Yeah, I think it's 2 floors in the building of the National Library of Medicine.
Okay.
And they work all night because I've been on that campus late at night. And if they weren't, hopefully they weren't just, the cleaning people cleaning up. the,
But
you
the
know,
lights were on
the
and
lights were on and they were busy working. So,
Mhm.
you have to because it's a 24/7 operation.
Mhm.
And it's really, I don't know how it's faring in the current environment, but, really has been one of the glories of American biomedical research worldwide, a gift to the world, really. So,
Mhm.
but not cheap to run.
Mhm.
And I forget how many. I lose track of how many articles. It's something like 26 million articles now, and it goes back. There are articles in PubMed dating from the 18th century.
No kidding.
I think the first article on cancer. I once looked this up, but it dated from, I think, Benjamin Rush, who was a signer of the Declaration of Independence.
Hmm.
So it's a it's an awesome undertaking, and it used to be bound books, Index Medicus. I hate to admit I'm so old that when I first started doing this sort of research, it meant going to the library and on a long table they like at Cornell Medical School Library where I used to do a lot of research. I mean, like 30, 40 feet of books going back to the 19th century. So you would had a way of looking in that Index Medicus. It was an index of medical journal articles. So
Hmm.
complicated process compared to what it is today. It's phenomenal progress. But that's the origin of it. It really, I think it dated from about the Civil War time.
Mm-hmm.
But then they went back and they added in older articles yet. So it's pretty amazing.
Mm. All right. So you're in PubMed,
Yeah,
you're looking at the journal articles, and you're trying to pick out which ones to read.
yeah,
They've been vetted by the peer reviewed journal that they were originally published in,
yeah,
and now they're being vetted again by being added to PubMed through their machinery, people who are reviewing them and maybe writing back and forth to tell people,
yeah.
yes or no based on these criteria. And then they finally end up getting published in PubMed. You still have to make a decision about which ones to
Yeah,
value.
right. Well, first you have to decide which ones you're going to read because you're presented with a whole, panoply of menu of many articles usually. I mean, there are topics that have never not been researched, but you pretty much can find something if you can think of it. It's probably there are probably somebody else in the world has thought of it already and published something on it. But usually, almost always, I go into PubMed with a particular question in mind. So the research question, I said before that it has to be a clear and important topic, but for me, I wouldn't be spending my time looking for that subject if it wasn't already, in my mind at least, a clear and important topic. So I'm looking for something that will correspond to the idea that I have. I might have a theory, just a wild surmise, not a developed theory, but I might think, I wonder if talcum powder causes cancer, let's say. So this is important to me I'd say, for various reasons. So I'm going to look for that particular topic. Now, if there is a paper pertaining to that, and by the way, there are, then I know I'm in the right area, and I'm now going to look at the different papers that are out there. And so the first thing is, aside from it being an important research question, is are the study methods that are being used in the paper strong and appropriate? So this is a very important, Ben, because sometimes you find a study that's on the topic that you're looking for, but the method being proposed isn't the appropriate one. For instance, you may have a question relating to the clinical value. I don't want to take talcum powder, but let's just say some natural substance. You may have a question about the effectiveness of that
Right.
in treating people with cancer. I'm sure you do. So, but what would be the appropriate research method for studying that? And this is the biggest problem that we have in our field, which is that there's a lot of laboratory research on the topics that we investigate and relatively little clinical research on those topics. So you could say, yes, mangosteen does seem to kill cancer cells. I always pick on mangosteen
I know
because,
you do.
poor mangosteen.
I
Most,
know.
most people don't
It'd
even
be
know
funny
what
if it turned out to be the cure for cancer.
my luck.
Okay. So,
But
yeah.
you see
So,
what I'm saying?
no,
But
I
you
do.
could pick and there are many, and I don't want to get us filtered out by YouTube, but we could mention other much more famous, quote unquote, alternative treatments
Right.
that validly can be criticized for not having convincing clinical data. Now,
So I'm sorry, I don't mean to interrupt,
no,
but
no,
I always think about what our audience may or may not know. And in this
yeah.
case, the terms in vivo and in vitro are referencing either in the laboratories, like in a test tube type of study, or done with human beings. Is that right?
Well, not exactly.
Okay,
So
maybe you
in the
okay.
laboratory, you could have three kinds of. I'm sure there are more, but you could have mainly three kinds of research, which would be in vitro means in glass, so that could be in a petri dish or a test tube.
Okay.
It could be in vivo, which could be in a living system, meaning mostly
Okay.
a mouse or rat, lab rat, which is decreasingly common or important, and in silico, which means that you ran it in a computer simulation,
Okay.
which is increasingly important. For the human situation, you would look for the word clinical,
Okay.
human clinical, because clinical could also be veterinary.
I see.
Yeah. So, technically speaking, human clinical research could also be called in vivo, but it's not usually used in that way. In vivo
Okay.
usually refers to animal research.
Oh, good to know.
Look, let's say that I found an article, but on the one hand, it didn't have any clinical data in it. It was only about the effect in test tubes, basically in vitro or other kinds of laboratory research. Well, what question are we asking? Do you want to know if poor mangosteen, if mangosteen cures or or improves the survival of people with cancer who have already established cancer? Most of the research wouldn't answer that question.
Right.
So it's interesting. You sort of tuck that away in the back of your brain, but it isn't what you're looking for. It isn't the appropriate question. On the other hand, you could be too rigorous in your criteria. Why two? Because there's oftentimes there's a kind of verbal game that people play, which is with people in authority will say, well, there is no convincing clinical trial data. But what would be convincing? Well, that's a shifting criterion
Right.
because clinical trials are very relatively rare compared to laboratory research or anecdotal research. So you may be only able to get a less rigorous type of clinical trial situation. And clinical trials come in 3 or 4 flavors, and they're phase 1, 2, and 3, and there's also a phase 4, which we don't have to go into. But these are of increasing difficulty, increasing size of the trial, the number of people involved, a number of participants involved, and the methodology. So a phase 3 trial is a randomized controlled trial. This was a type of trial introduced in the 1940s, basically, proposed in the 1930s in England and then in the UK, and then implemented in study of antibiotics for TB in the 1940s. It's a highly formalized type of trial where some people are getting the actual drug and other people are just getting the placebo or some other treatment. That's a high quality, and nowadays very expensive to conduct, and many millions, maybe hundreds of millions of dollars. My opinion, a drug or a treatment has to fulfill 2 sets of criteria. One is that it works, and the second one is that it's going to make a ton of money for whoever is investing the upfront money to get that thing tested. And we've seen endless examples of good treatments that reach a certain point and then can't go any further because of the economic issue. I mean, remember when I did the interview with Jim Allison a few years ago, who basically invented the immune checkpoint inhibitor field, and if you remember, the very moving story that he told of almost how that whole treatment died on the vine because they couldn't find an investor willing to put in, at that point, relatively modest amounts of money to prove the clinical effectiveness of that kind of treatment. And the world would have been much worse off if that had happened. But luckily, because of a variety of factors, everything kind of luckily lined up, and then it was proven, and it's now top-selling drug in the world.
Yeah.
You
I
know,
remember that conversation well, and I'll put a link in the description or
yeah,
up here somewhere.
yeah, and that's not unique.
Fascinating info.
That's the rule. That's not the exception. I mean, that's the exception to the rule. That's
Right.
not an odd one-off. That's actually how the system works, and we can love it or hate it, but it doesn't change the actual picture of it. From my point of view, when I say that it's on a strong and appropriate study method, for my purposes, an appropriate study would be a phase 2 clinical trial. I think if it's a non-toxic agent or substance, that is tentatively actionable, because if it's non-toxic, if I'm telling you that the grape juice benefits, people who have a particular kind of cancer, and you have data where 12 people were benefited from this, let's say, and you can show what the benefit was or whatever, then it becomes meaningful. I'm not happy with the fact that that it's at the 12 people phase, but it's what we're going to get realistically. Now, if it's a toxic substance, that's entirely different, because then you're asking people to risk their health and their lives based upon supposition. All you've lost is some hope if you thought the grape juice was going to help you and it didn't help you, but you're not really much worse off for doing it.
I think of people who are trying to discover whether or not grape juice might be helpful to them
Yeah.
and what it is that they should be looking for in some PubMed research article. And a phase 2 clinical trial would be at the highest level that something of that natural origin might reach. Oftentimes we see it doesn't even get to a phase 2 clinical trial. For it to be added to the knowledge base for medicine, it has to be approved by the FDA. And that approval requires, as one of its criteria, a full blown phase 3, at least, clinical, randomized clinical trial.
For drugs, not for procedures per se. I mean, what happens in practice is that there are two worlds of medicine in the U.S. and in some other countries, where FDA basically could say, "Well, it's harmless. We don't have any evidence that it does what you claim that it does." But you're not if you don't make therapeutic claims, claims of cure, then and you restrict yourself to just sort of generalities, good for your health or good for your
Right.
metabolism, or there's whole vast books of regulation and precedent relating to this, and people in the industry know how to phrase things. But you're relegated to a lesser category, which is the food supplement industry.
I bumped into this issue where it comes to the Mycolife mushroom products and my involvement with that company to produce a food supplement has been a learning curve for me in terms of understanding what you can and can't say. And nowhere on the Mycolife site does it even say the word cancer.
Right.
You couldn't even mention it,
Right.
even to share a study. In fact, from what I understand, if you have a research article, you can't even link directly from a research article to a product. It has to be at least two links away, two clicks away. So anyway,
Yeah.
there is a lot of regulation, and
Right.
it's we would love to be able to tell people just flat out X equals Y in this realm of natural substances. And we constantly are trying to work around that by sharing, in your case, the results of scientific studies that show specific evidence in the laboratory, very clearly stating, here's what the lab results stated, and here's, what they found, what the results were.
You raise an interesting point because mushroom extracts like of shiitake and maitake and Coriolis or Trametes versicolor, there is clinical data on that. In fact, those both shiitake and Coriolis were made into medications in Japan and China back in earlier days. It's now getting a little older, that data, but they are or were widely used and approved as adjunctive, meaning not as primary treatments, but as additive treatments. So that's an unusual situation, which came out of the political climate in China after the time of Mao Zedong, and the particular situation that prevailed at that time, which eventually gave rise to Nobel Prize winning work. And Tu Youyou, who was the first Chinese woman to win a Nobel Prize, won this for her discoveries of artemisinin and artesunate, which were ultimately derived from traditional Chinese medicine. And this was in the heyday of the Maoist era, when Mao told researchers that they should look back at Chinese traditions, traditional Chinese medicine, TCM, for cures. And lo and behold, it turned out that, at least in the case of artemisinin, which is basically Chinese wormwood, that there was validity there, and it became the number one or number two top selling drug for malaria in the world. So, there we know, I mean, this is no secret. I mean, we know that there are treasures in traditional medicine, and there's a lot of dross and worthless stuff too. So it's worthy of further research. But I think from a capitalist point of view, which is almost the entire drug industry, it doesn't make much sense financially to spend a lot of time researching something that would be then available to all at the end of the day.
Right.
So they're very good. The drug industry is very good at getting leads from traditional medicine, but it doesn't really want to. It doesn't have the motivation to follow that up and make things natural, widely available. It's totally against their financial interest to do so. What goes through my mind? Basically, I'm looking for something that answers a particular question, whether that's about mangosteen or some treatment for prostate cancer or whatever. I have it in. There's a reason why I'm browsing in PubMed. I'm looking to make sure that the study is honest and complete. One thing you can look at is that some people said that it's more important what you find to be not proven than what is proven. In other words, an inferior paper, as far as I'm concerned, doesn't raise the question of where its own limitations might lie. But the honesty part is to present the data so that people can see for themselves what the strengths and weaknesses are, because every paper has strengths and weaknesses. So are you honest about where there are still gaps in your own knowledge? And a very important thing, and this is very personal to me and to my history, is that the conclusions of the paper should match the data. This is sort of where I came in to the field because of my involvement with Dr. Sugiura at Sloan Kettering, where the paper that Sloan Kettering presented to the world had Dr. Sugiura's data embedded in it. But the conclusions of the paper, which were the opinions of the leadership of the center where I used to work, in my opinion, didn't match the data that they were presenting. Very peculiar, but this it also could happen inadvertently. If you show that you can kill cancer cells with a particular substance, and you conclude that this is a useful cure for cancer, that's ridiculous. You haven't proven that. You went way beyond what the data showed.
Right.
And then also, I would say, I would look at things. Of course, I'm going to look at where the paper's coming from. Very often, I'll have to look up on Google, an institution if I never heard of the institution. And I'm trying to think of there was a treatment a while back that was very popular for a while. And when I looked up the institute in Philadelphia, where this paper originated, it was somebody's house. I looked up on Google Maps. It was a guy's house, and he had an institute. And it wasn't a crazy paper. I'm sort of blocking on what the topic was, but it's not really that important. The point is that if you never heard of the researcher, there should be some affiliation there. Who's behind this? Who's standing behind this? And who's proposing this? Because as a general rule, the people who are making the statements should be qualified to make those comments. Now, I say this with all modesty because even though I say that I've written about 12 journal articles, but most of those are co-authored with the research scientists or the clinicians who are doing the main work. I mean, I hope that my contribution's been valuable. They tell me that it has been, but I wouldn't say that I stand on my own if I started making claims about research I'm not a laboratory researcher. I'm a good reader of the medical and scientific literature, but I'm not a medical researcher in that sense. So, the criteria, the credentials. I'm not overawed by people's titles, but it's important, and also who's standing behind the paper.
Yeah.
So when the cancer stem cells were first discovered, it was important to note in the first description of cancer stem cells in solid tumors took place at the University of Michigan. Uh, and Max Wicha, who was the senior author, and I'll get to that in a moment, what that means, was, I believe, at that time, the head of the cancer center. Okay, similarly, Jim Moray, whose Oncoblot test is how I discovered my prostate cancer, was the founding director of the cancer center at Purdue University. So and we could make many other examples of this. So who's behind it? Who stands behind this? Who's put their hard-earned reputations on the line? Makes a big difference. I definitely sat up and took notice that Max Wicha was putting his reputation on the line behind the discovery of the cancer stem cells in breast cancer. And indeed, I mean, in my opinion, that work was really worthy of a Nobel Prize. I mean, I would go back to the work at University of Toronto and John Dick and the other people in Toronto who discovered stem cells, period. Never got the Nobel Prize. The discovery of stem cells or the discovery of cancer stem cells in leukemia or the discovery of cancer stem cells for many other, no, never got the recognition that it deserved, which is a whole nother topic we should talk about.
Well, I think we will.
Yeah.
So the
So,
criteria of the origin of it, the institution that the researchers or the
yeah,
presenters of the paper, the authors of the paper, I
yeah,
should say, that they're affiliated with.
very important. Look, to take something closer to our own involvement and experience, which is fermented wheat germ. Do you think it's nothing that the most famous scientist, maybe living scientist in the world, Jim Watson, the co-discoverer of the double helix of DNA, put his name on that paper? I mean, come on. That tells you that already. It doesn't automatically validate all the data, but it tells you that there are very credible, brilliant people who are involved in this. So I take notice of these things. It doesn't mean that somebody who's an unknown to me necessarily isn't wrong or can't be brilliant or so forth. But I think this is how we sort of position the paper, where it sits and where it stands in the general scheme of things.
I assume that the average lay person would be able to get most of this information of the institution and the authors in an abstract because I've looked at some abstracts and been able to read through them. They're written in, scientific but plain English, where if you then get the full text, you sort of need a degree in chemistry and microbiology or cellular biology in order to even get your head around some of the concepts of the interactions of chemicals with cellular tissue and so forth. But the abstracts, in by and large, they do a pretty good job of explaining what the paper is about,
True.
and those points are in the abstracts. So
Right.
I think it's important to note that, of course, there are going to be criteria that are contained in the full text that relate to cellular biology and chemistry that the average person is not going to be able to look at and vet it and say, oh, that compound doesn't really, bond or, whatever types of information that, a true scientist would be able to look at and vet. So that leads me to the question of what else is there, let's say, in an abstract that we could look at that would be understandable by a layperson to help them continue to refine and really put a value on a paper.
Well, you're right. I mean, you make a very good point because very often I never go beyond the abstract in a paper. If I'm moderately interested, I'll read the abstract, but I oftentimes won't go further than that. I just want to say though that Lloyd Old, who was among the most brilliant people I've ever known, was the vice president at Sloan Kettering when I worked there. He had a beautiful writing style. And you'd think that, well, what difference does that make? He also was a musician and had an interest in arts and literature and so forth. I think there is some connection between the beauty of the language and the beauty of the ideas that are being expressed. I'm dubious of papers that are written in such a complicated way that an intelligent non-specialist couldn't understand them. He didn't think that was the case, and he made so many discoveries in basic science. I mean, everything. I remember at his funeral service that one of the big leaders of the field said that Lloyd was really the godfather, if not the grandfather, of the whole field of cancer immunotherapy. And Jim Allison stepped into his shoes, literally into his positions at Cancer Research Institute. So I wouldn't say that it's unimportant in terms of the style even of the paper. It should be written in a comprehensible, elegant, or readable way. It's important.
And that's been one of the things that has helped your career along is that you are a terrific writer and you help to break down these complex scientific topics into a language that people can understand and find it very relatable and comprehensible. You're fortunate to have known someone who was good at both, but I would venture to say that probably is not generally the case.
No, it's not. And sometimes people use language to obscure things that they themselves are not really sure about.
We got an email from a viewer, something that happens with some frequency, and this one really got my attention. And I sent it along to you and was expecting maybe a little enthusiasm for the subject or the conclusions that the viewer was offering in their opinion. And surprisingly, you didn't feel that it was meritorious, I guess is the word. And I'd like you to sort of break that down for me, if you would. Just tell me you looked at it and came up with your conclusions. So, what did you see and what were your conclusions? And can you share that paper with us or
Sure.
what the criteria were?
So, as people may know, I'm currently under treatment for prostate cancer, and I'm receiving radiation therapy. And this was my decision. It's one of the most difficult decisions I've ever had to make in terms of health affair. So it's rather close to home for me, this topic, and I appreciate the fact that this person shared his insights and his opinions with me. In no way do I mean to denigrate what he's done and what he believes, but his reading on this very, very important paper that came out about 2 years ago in the New England Journal of Medicine was very different from my interpretation of it. His interpretation was basically that the paper showed that taking radiation therapy for prostate cancer was no better than doing nothing, or what we would call long term
Watchful
surveillance.
waiting.
Yeah, well, could call it watchful waiting, surveillance, basically. My reading of that paper is quite different. Quite different. Although there are some very surprising things that, on first sight, would lead one to question whether or not it's even necessary for you to have prostate cancer treated. society wide. So I'd like to just sort of walk you through, if I could,
Sure.
what leads me to my conclusion.
Before you do that,
Yeah,
I want to just say that we all are very appreciative and grateful of your continuing to work with me to make the Moss Report podcast, despite what you're going through personally with your own health.
thank you.
And I don't want to get too deeply into your own personal
Yeah,
routines and things, but let's just say it definitely poses challenges,
yeah,
and I think it's worth noting that
thank you.
you're
Yeah.
really a trooper.
Well, thank you. It's also, difficult for one to discuss papers that hit close to home. So this is a case where, I mean, look back on my own career, and sometimes I would write about topics, perhaps not always bearing in mind how this would affect other people who are actually in the struggle at the moment. I tried to, but it perhaps didn't always succeed. So it was sort of brought it home to me that we have to, when we talk about cancer, especially difficult to treat cancers, and mine has some aspects of it that are a little bit difficult. We're talking about human beings. At every single one of those cases, those numbers, I mean, is a person's struggle for their life and for their health and so forth. So it's a difficult to be a truth teller in the field. A lot of people feel like, and I'm that type of person, that they have a compelling need to sort of clear the air and to tell what's really going on and so forth. But you're talking about people's lives, and it's somewhat different when you yourself are involved and you become the subject of this. So just to bear that in mind. This person also, if I'm remembering correctly, Ben, was also the same person who had some interesting evidence about a compound in strawberries.
That's right.
But so you have to wonder what the relative strength is of the evidence for radiation therapy of prostate cancer vis-a-vis the strawberry treatment of prostate cancer. I don't mean to be facetious, but these are life and death questions for me.
Right.
These are not purely academic, and I think it might surprise some people that I opted for the route of radiation, conventional medical treatment for my condition. And it surprises me in a way that I did, but I do believe in, the value of complementary medicine or alternative medicine, but I also believe in science, in the validity of scientific findings. So I had to balance those two things. And let me show you the data on this, and I'll have a bunch of slides that we can put up for our listeners to look at as well.
All
Yeah,
right, so this is the article that you had a different read on from
right.
our viewer.
Correct. His read on this, and I could understand how people would reach a conclusion like this, was basically that there wasn't really any difference between the outcome of doing monitoring, which is also called that watchful waiting, surgery, or radiotherapy, which is another name for radiation therapy for prostate cancer. And this was an actual randomized controlled trial. This wasn't just an observation.
Look at
And
all those authors
yes, everybody, yeah, as they say, success has many parents. And the
and
affiliations,
affiliation.
University of Oxford, Bristol Medical School, almost like every major hospital in the UK.
Okay.
Yeah. And then so it's actually a 15-year follow-up. Now, this is also very interesting because sometimes you see after 6 months, the patient didn't have any more cancer. Yeah, tell us about what happened 15 years later. Some of these were up to 21 years later. So the study started we ran between 1999 and 2009, and it initially involved 82,000 men who received PSA, prostate-specific antigen testing, and from those, cancer was diagnosed in 2,600 of them, and 1,600 enrolled in a trial, and 500 or so were assigned to receive active monitoring, which meant basically getting a PSA test every 3 months, I believe, and seeing the doctor and having other, tests to see whether the cancer has recurred. And then 500 or so underwent prostatectomy, which is surgical removal of the prostate, and another 500 or so underwent radiation therapy. So that's a pretty good design.
Hey, there's a lot of people involved
You need
over a
that.
long period of time from a
I,
good. Okay, so
I,
but
I,
so the difference that you had was a difference of interpretation of
yeah,
the results.
correct. So what was the goal, the stated goal? Because in a paper, a clinical paper, you want them to state up front what their objective is. Because if you
Okay.
don't do that, somebody could then go fishing in the data and could say, oh well, in people who have one green eye and one brown eye, there was a significant improvement in survival. There only were two people with that condition. So you want to have pre-specified topics. So they had a primary outcome, which was death from prostate cancer. That's pretty clear cut, you would think.
That they were trying to see
Yeah.
how long a person survived once diagnosed, given those three options: no treatment, radiation treatment, or surgical removal of the prostate.
Right. They wanted to see how many of them died of prostate cancer.
Okay.
That was the main goal.
Okay.
Then there were three other goals, three other outcomes. One was death from any cause. A next one was metastasis or disease progression, metastasis being distant spread of the disease,
Right.
and the third one was the the point at which they had to start, or they started taking uh, androgen deprivation therapy, which is hormonal therapy to counteract testosterone, to counteract the male hormones.
Right.
And then there were some numbers given about how many of them were involved in those different choices. And as a note, 1/3 of the men had intermediate or high risk disease, and we'll get more into that in a moment. So, first of all, this was sort of the takeaway of our correspondent, which was in survival outcomes, and this I think came as a big surprise to a lot of people involved in the study and a lot of people in general, that in that huge group, the deaths from prostate cancer only represented 2.7% of all the men in the study.
Huh.
And of that 45 men, or 2.7, here's the breakdown: that 17 of them were in the active in the watchful waiting group, 12 were in the prostatectomy or surgical removal group, and 16 were in the radiotherapy group.
So
The P number
pretty
is,
equal.
so they were pretty equal. So basically, there was only a 0.2 of a percentage difference between the radiotherapy and the active monitoring.
Hmm.
So you might conclude, and I must say, when I read this paper, it did kind of surprise me and made me, gave me a little bit of a feeling of wondering whether I had made the right choice, even, because that's not a very big difference. But also, if I'm not mistaken, I don't have this gentleman's letter in front of me, but I'm pretty sure that at that point he translated these absolute numbers into relative numbers. In other words, you could say that there is a difference, not significant, but a difference between the percentage of people who had who had survival with active surveillance, it actually wasn't that much different. There was a bigger difference between prostate and radiotherapy, between prostate surgical removal and radiotherapy. But the P number, I won't go into technical details, but this means that
Well, this is important. This is what we're talking about, the understanding
yeah,
the
this is
merits of the
more
paper.
this P number means non-significant. So it means that there's a less than 20%, greater than 20% chance, of it being due to just accidental factors. So therefore, that's the conventional cutoff for what's quote unquote statistically significant, which is really an arbitrary number. But that's how scientists. This is how the whole field developed from the 1940s on. I would say that anyway. I mean, common sense would tell you that these numbers are almost identical. There really is
Right.
there's no significant difference
So the
in deaths from
conclusion,
prostate cancer of the people who took treatment overall in a group where most the people had a lower Gleason score than I have, meaning a less aggressive cancer. If you take the whole group, there wasn't much difference.
and that was
In
the conclusion I believe the gentleman who sent us the
correct,
email was drawing, was that in that in that light, you could say, why bother getting radiation or having your prostate removed if the watchful waiting resulted in the same or generally the same number of deaths from prostate cancer.
right.
So, but if I'm guessing now, if we read further, there's a little more to the story than that.
Right. And as an alternative, he was holding up his strawberry idea, eating for organic strawberries.
Now,
But
we
again,
appreciate that,
right,
him
of
thinking
course,
outside the box and looking at
absolutely,
data on, I mean, that's the kind of thing that we strongly encourage everyone
right,
to do in terms of digging into the
right,
science of natural medicine and also understanding the relevant clinical data on treatment.
correct. And after all, my book, The Morse Method, it's no different in philosophy or principle than what he's proposing. It's just that I have a somewhat different criteria for choosing which supplements one or which foods, special foods one should take.
Right.
Some of which I'm doing actually.
Now, your analysis of this paper is going to be instructive because I see it the way that that gentleman saw it.
Right.
So tell us, where did you see the variance?
Well, let's look at metastasis. More
Okay.
men who didn't get treatment, I call that watchful waiting or active monitoring, different terms for the same thing, got metastases than the ones who didn't. So in the case of active monitoring, in the end, and the end being 15 years of queries to the people, see how they're doing, 51 men or 9.4% in the active monitoring group had metastases.
And if I
And in the
recall,
yeah,
mostly metastases from prostate goes to the bone.
correct, which is very painful usually.
Hmm.
4.7% in the group that got the prostatectomy or the surgery, and
Oh,
5.0
they also had metastases in that many who had the prostate removed.
because there were probably already micrometastases that had spread from the prostate or between the time that they had their biopsy done and the time they had their operation, which might
Hmm.
have been longer in UK than in the
Right.
US for economic reasons.
Right. Because they
They
have the
might have.
NHS and the.
And there's some in there. I won't go into this because it's extremely interesting biologically, but it's not relevant to our discussion.
Right.
That it seemed as if, in many cases, people actually had more aggressive cancers than they were initially diagnosed with.
Hmm.
The biopsy process is incomplete in terms of telling what really goes on, because when they would study the whole prostate gland, they would oftentimes find that there were parts of it that had a higher malignancy.
I was going to say, what
Yeah,
was the rate of metastases among radiotherapy patients?
5.0, 5%. One,
5% in the
right,
radiotherapy group.
right.
Let's break that down one more time. So in the watchful waiting, it was how many percent?
9.4.
Oh, so
So
nearly twice as many.
correct.
Okay, so that's another way to phrase this then. You could say twice as many
Yeah,
people in the watchful waiting group
yeah.
got died from metastatic.
No, no. Because the dying part, um, we said already that there wasn't any big significant
Oh, I
difference.
see.
The
Okay, so we're
re-
just talking about the fact that they had a progression of the disease, that it metastasized.
correct
So
that measure of
almost twice as many people
right,
who were in the watchful waiting group had metastatic
right,
cancer develop.
right,
So 9.4 versus 5%.
right.
I see. And so that statistic is very important.
I'd say. And I think, given the fact that this study started in, like, what do we say, back in the end of the 20th century, I mean, radiation has made some big advances
That's right.
since then. So I would think that the number would be even smaller here.
And also, the relevant side effects of the treatment have diminished due to the different advancements,
Right.
some of which you discuss in your cancer journey series as well. The devil's in the details.
Yes. So when the people active monitoring group got their metastases, like suddenly they have break a bone, or they have pain in a bone, then I didn't see the exact number, but you could be sure that the vast majority of them then were put on hormonal therapy or anti-hormonal therapy, what they call androgen deprivation therapy, ADT. So now we get into
Which
the
has its own consequences.
correct. But let's now talk about some other things here. So let's
Sure.
look at the next one.
Okay.
More men without the treatment had to take ADT. So this is what we're talking about. So
Right.
long-term ADT could also be given short-term. Like, for instance, it was offered to me along with my radiation therapy. I turned it down for reasons I could go into. But basically, that's one kind of ADT. But the other kind of ADT is when it's given indefinitely. And 69 men, or 12.7%, in the active monitoring group had to go ultimately go on long-term ADT, whereas in the radiotherapy group it was 7.7%, and in the prostatectomy group it was 7.2. So it wasn't quite half as many, but it was a for me a significant number of people.
Yeah.
Okay, so you see what happens here. What we're talking about experientially is, yes, you could say, oh, well, why don't I just monitor this and see what happens, right? You
Because there's
might,
no difference
right, because
in
there's
the
no
death
difference
by
in
prostate
prostate.
cancer
Exactly.
number.
But the reason there's no difference in death by prostate cancer is the great majority of prostate cancers are slow growing. And the treatments have improved over the years. And after all, that business of removing testosterone, Huggins won the Nobel Prize for that in the 1940s. That was one of the very first treatments there was for any stage 4 cancer. Now we do it with drugs. In those days, they did it through surgery. And there's one other thing,
Sure.
and that is that more men without treatment had clinical progression, meaning that of any kind, that there were signs and symptoms of the disease progressing.
Uh-huh.
That's 25.9% in the watchful waiting or active monitoring group, 10.5% in the prostatectomy group, and 11% in the radiotherapy group. Looked at another way, only 24% of the men were alive without any prostate cancer treatment at 15 years. Now, some of them died, of course, of other causes because it
Right.
tends to affect older people.
Right.
But that's a pretty big number. Looking at that, looking at it this way,
Yeah.
progression occurred in almost 26% if you just opt for the watchful waiting or the active monitoring, whereas
Progression has its own
one
progression.
out of four or so, whereas 1 out of 10 or so if you opt for treatment. So this is what I had to look at, this
Right.
whole picture. And
Right.
you see, it's like to say to somebody in my situation, well, don't bother with treatment or take your own natural. I wrote a book
Hmm.
on this topic, right?
Hmm. Not that that's what the writer, the person who
No,
wrote
no,
it
no.
in was
I
saying,
don't mean to pick on
but
that
no,
part.
but people do
Yeah,
get fixated on an ideal or a
yeah,
number
yeah.
of something that they think means one thing, and there's other ways to interpret that data as you're showing. And I think it's incredibly relevant, and not just for you,
All
but
right.
across all of the aspects of trying to make sense of the numbers that are presented here. I think we're running a little long with our
Yeah.
podcast, so
Okay.
I'm going to say we will put the full notes that you took and all of the other parts of this.
Yeah.
Was there anything else in this study that you wanted to
I just wanted to
go over?
say that, you know, there's an old saying, that theory is gray, but green is the tree of life. That I think Goethe was the one who first said that, and it's quite a different thing to analyze a study on paper or on your computer screen, and I don't direct this at any individual, and to live it. The experiential part, that's what I had to try to extract from reading all these numbers and everything. What's my life going to be like if I take one course or a different course?
Mm-hmm. Yeah.
And I could see, and especially now we add in the fact that there were some aspects of my situation, including the fact that what I have, technically speaking, could be considered a recurrence of my cancer that was treated with cryoablation 10 years ago. But it looks to me like there's a pretty good chance that if you take the watchful waiting course, pretty good chance you're going to wind up with metastases, painful metastases to the bone, and winding up anyway on this chemical castration or androgen deprivation therapy, as they give it the nicer name, um, about a 1.25 or more chance. And if you have a high risk cancer, maybe even a higher rate of that. So that's having seen a few people close to me who died of advanced prostate cancer, including the aforementioned Lloyd Old. I trying to avoid that. I don't want that to be my fate.
Mm-mm.
I don't, I really feel like I would do, a lot, and I'm doing a lot to prevent that. Now, you could say, what about all the alternative treatments? Well, we could talk about that some more because we've also run into some people who think that it's contradictory for me to having written so much about alternative treatments not to use the alternative treatments. But that's not exactly the case because as
Well, I know why. Because you've had a good solid 10 years with no evidence of
correct,
disease, that it's
right,
been very slow progressing, and that you're doing everything holistically possible in
yeah,
ways that we've discussed in terms of nutrition, in terms of supplementation, in terms of, your own activity, physical activity, all of it, in order to have the holistic lifestyle to give yourself and your body the best chance to heal. I don't mean to speak for you, but I know that you're doing that. And I'm not as much worried about your outcome as maybe you are, because I know how
yeah,
diligent and thorough you are in general,
yeah.
and how you really practice what you preach where it comes to nutrition and so forth.
I'm
And
trying.
you're,
Thank
you're a
you.
strong person, and I
Thanks.
applaud you for all of your efforts, not just with us and what we're doing together, but on your own in
Thank you.
terms of really doing the work that's involved in trying to heal from a disease and prevent a recurrence. And it's not, you know, it's not contradictory as I
Yeah.
see it that, you're not
Right.
doing something. You are doing it. And it's been successful, and we hope
Yeah.
to see even further success.
Well, I think also, Ben, that, you know, as much as I have criticized the medical establishment over the years, you really have to admire the degree of detail in a paper like this. So, this is a model paper.
Mm-hmm.
You could learn an awful lot studying this, just studying this paper.
Mm-hmm.
As I said, it checks all the boxes. But would that we had data like this for the Moss method or for the various components of them? We have some data,
Right.
and we've talked
Yes, we
about
have.
this. And some of the things that we have data on are some of the things that I'm doing,
Pomegranate,
like the
modified
mushrooms.
citrus pectin,
Correct.
mushrooms.
I'm doing all of those.
Right. And they do have clinical data on those things.
But
So,
we don't have the robustness of the detail of solid studies like this. But again, there's a lot that goes behind this. Look, I mean that's a who's who. That
right.
list of all those people involved in this study, it's phenomenal.
No, but the science that we do have for the natural ways to help fight cancer is
Yeah,
solid enough
yeah,
and actionable and non toxic. And also, it's not intended to be primary
no,
as a treatment, it's complementary medicine in the
right.
very definition of the word.
I think it's going to be that for a long time.
So, in addition to the notes that we have from how you analyzed that paper that will accompany this podcast on themossreport.com, we're also, and we have updated and offering a free download of the DIY guide, the do it yourself guide to cancer research. Probably one of our most popular downloads ever. And it chronicles your whole process of going through and doing research into the conventional treatments for cancer. Okay, anything else you want to add before we wrap up, Dad?
No, I think this is a very, very interesting and very worthwhile discussion from my point of view. Helped me to clarify my own thinking, so that's very, very nice.
And I'm always learning from you, so thank you for teaching me.
You're welcome.
So for now, for the Moss Report, I'm Ben Moss. How are you healing today?